Assalamu alaikum and welcome to the EL224 course, that is the microprocessor based systems. In this introductory lecture, I would be discussing some basic points about the microprocessor, and we would be having a very holistic view of the subject and the microprocessor as a whole. Right. So before we start our discussion, we can have something like some points like the complexity / integration, and then the multiple system on chips, multiple processor system on chips, multi-cores, prototyping and manufacturing. Now the whole story of the microprocessor stems down to the fact of designers being able to create complex circuits and the integration technology enabling the designers to place that number of transistors in the circuits. So that is basically the important thing. So basically the story goes like, for example, if we have a part in my drawing, it's supposed to be a square. Let's say if we have a 1 millimeter square area of silicon wafer, right? So the amount of gates we could place in this 1 millimeter square area would be referred to as the integration capabilities, right? So as the number of gates that we could place in this area increased over time, the designers were able to increase the integration capability of their integrated circuits or ICs. This is an integrated circuit or an IC, right? Single piece of silicon. Now of course the chip designers were also able to create more complex circuits, so they could place the whole complex circuits easily in this silicon wafer or integrated, because the integration technology allowed the scientists to do that. In fact, the concept of multi-cores became popular just for the same reason, right? In a multi-core arrangement, scientists or designers were able to produce a single core. They could produce a single core, they could debug that core, verify that core, and once that core was debugged and verified, they could place the core on the silicon wafer or the silicon IC, and they could also copy that working core and produce the concept of multi-core processors, right? So when the scientists were producing multi-core processors, the multi-core processors allowed the scientists the benefits of less development time for a complex chip. You know, multi-core is nothing, it's just a repetition of the cores that have been produced before and tested. So producing a complex circuit becomes very easy in the form of multi-cores. Of course, multi-cores are favored by higher integration capabilities, so that the multi-cores can take care and they can offer the higher integration capabilities of the integrated circuits. In fact, multi-cores offer less development cost and less development and verification time, and so scientists are able to create complex circuits. So that's why multi-core processors have become so popular, right? Then of course we have the system on chip, which is a complete microprocessor based system on a single IC. So what would be a complete microprocessor system? It would consist of RAM, ROM, CPU, interrupts, IO, right? So when all these components are in a single silicon IC, we call it as a system on chip. And if we have multiple system on chips on a single IC, they are called MPSoCs or multiple processor system on chips. In fact, multi-cores can be thought of as a specialized occurrence of an MPSoC or multiple processor system on chip. Then of course, when we are making these complex circuits, we need to test the circuits in hardware, right? So for testing, we use prototyping technologies. And if we want to manufacture So for production we can use manufacturing technologies. So these are basically used for production. Now of course manufacturing technologies are very expensive, so we cannot use the manufacturing technology for prototyping. Manufacturing technology examples include VLSI, right? ASIC is another example of manufacturing technology. So these are used as for the production of high volume applications. For prototyping we use inexpensive technologies like FPGAs, which would allow us to prototype the processes really fast. Now in fact multi-cores ideas can be termed in the fact that the cores themselves can be of different types. They can be bulldozer cores, which are very powerful cores, and they can be termites, which are very less powerful cores. So for example, when you look at GPUs, when you are looking at the documentation of graphical processing units or GPUs for your PCs, the GPUs contain lots of cores. They might consist of 50,000 cores, 100,000 cores and so on. So don't be overwhelmed by the number of cores. They might be simple termite cores. They might not be very high performance bulldozer cores, right? So having multiple cores and operating those cores at lower frequency can help us bring down the power consumption. So power of your circuit can be reduced by operating multiple physical cores at lower frequencies. For example, if we have a quad core processor consisting of 4 cores, then the 4 cores can be operated at half the frequency or just 500 megahertz. So when we are operating the cores at lower frequency of 500 megahertz, that would mean that the power consumption of those cores would be much less than if the cores were operating at higher frequency of say 1+ gigahertz. So that is the idea. So the multiple cores ideas are also helpful in the term of reducing the power consumption of the systems. And some MPSoCs or some multi-core processor might have a combination of bulldozer and termites. So if you are doing lots of number crunching, if you are using 3D graphics, or if you are using engineering CAD drawings, then of course the bulldozer cores might be operational to carry out that lots of work. But if we are doing casual processing like web browsing, then the termites are just enough to carry out the task. You don't need a very powerful bulldozer core to do that. So the idea of multiple cores, making a single core and copying that core, helps us in reducing the power consumption as well. So this is basically some of the introductory ideas.